Hey kids, it's Dr. Runs here with your lesson for Objective 15. If you were absent or if you need a refresher, some homework help, this is for you. This won't be the most perfect, complex, exhaustive lesson on this skill. It's just something to help you get by at home. And of course, you can follow up with any questions that you need to ask from me in class. So we are doing an advanced skill of reducing irrational numbers in the form of radicals to their simplest form. So for example, if I were to calculate the square root of 24 using a calculator, I would get a decimal. And to write that, I would have to round it at some point. Say if I wanted to round to the nearest tenth, it would be 4.9. And by rounding, it's less accurate than if I keep it in the radical form. But what happens is these get large, and there's a way to simplify them so that we can use them a little bit more easily, in other operations. So, before we get started, let's consider square roots of perfect squares in a different way. This is a perfect square, 36, because its square root is 6. Well, another way to think about that is 36 is the same as 9 times 4. And conveniently, both of those are perfect squares. 9 times 4 is 36. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 6. So when we break down a perfect square, if it so happens to have other perfect squares that are factors, we can prove that the square root of 36 is 6 in a different way. It's kind of neat. So as we are going through this lesson, sometimes it gets a little bit hairy, a little bit overwhelming. The biggest thing to remember is this. To simplify the radicals, you'll factor out the largest perfect square and then simplify. And I will walk you through several of these. But before we continue, it is important that it is the largest perfect square, and it's also important that the factor is a perfect square, not just any old factor. So let me explain what I mean by that. So the number 8 has many factors. 1 and 8 go into 8, 2 and 4 go into 8. So all 4 of those are factors of 8. We're looking for the one that is a perfect square, which is 4. The square root of 4 is 2. The square root of 8 and 2 are decimals. They're irrational numbers. The square root of 1 is 1. This is a perfect square, but we want the largest one. So I will write the square root of 4 first because that's the perfect square, and then 2 because 4 times 2 is 8. And now I can simplify the square root of 4, which is 2, and bring down the square roots of 2. And if I wanted to check to make sure that I'm correct, I could put in the square root of 8 is 2.8 and some numbers, and I can do 2 times the square root of 2, and I get the same answer. So I know that those have the same value. Let's try another one. 45 has many factors, 1 and 45, 3 and 15, 5 and 9, and then we'll go through and we'll find the perfect squares. Well, 1's a perfect square, but I have a feeling there's a larger one, and it's 9. So we're not going to use these other numbers as factors because they are not perfect squares. So I'll list the 9 first. 9 times 5. 9 times 5 is 15. 9's the perfect square. Square root of 9 is 3 square roots of 5. All right, let's try another one. What is the largest perfect square that is a factor of 50? Now in our class we used this to help us. You are welcome to write down these perfect squares. There's a place for that here on your notes. Perfect squares are 1, 4, 3 times 3 is 9, 4 times 4 is 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and so on. And if you don't know them now, I'm sure by the time you've practiced this skill enough times, you will know them pretty well. So the largest perfect square that goes into 50 is 25 times 2. Square root of 25 is 5 square roots of 2. Now there is a trick to this. Perhaps you've caught on to it, that you should write the perfect square first. Square root of 4, square root of 9, square root of 25, and then the other factor following it, because when you simplify, this part of the expression comes first. We wouldn't say square root of 2 times 5. That's kind of weird. Okay. Please take a moment and try these next 3. Give this a pause, and then when you're ready, go ahead and hit play again. Okay, for this next one, the largest perfect square that goes into 12 is 4. 4 times 3. And then the square root of 4 is 2 square roots of 3. The largest perfect square that goes into 98 is 49 square roots of 2. Square root of 49 is 7, and then the square root of 2. Now with these larger numbers, kids will complain that I don't know the factors of, say, 98. What you can do is start with 98 on your calculator, 98, and then use your list of perfect squares and see which ones might go in. Of course, 81 isn't going to go in evenly, 64 won't. The next biggest one is 49, divided by 49. And it just so happens that, there's a glare, that it comes out to be, there we go, a whole number. So I know that 49 is a factor. But if I had divided by, say, 36, 98 divided by 36, that gives me a decimal. So I know that 36 is not a factor. And so that's how you can find factors of larger numbers that you may not be as familiar with. Okay. Now for the square root of 48, I understand that 4 goes into 48 12 times. If you write out all the factors of 48, you have 1 and 48, 2 and 24, 4 and 12, 6 and 8, let's see, oh, we forgot 16, 3 and 16. Okay, so we have all of these factors for 48. And 4 is a factor, that's a perfect square. But 16 is also a factor, that's a perfect square. So we'll choose 16 rather than 4. And I'll show you later in the lesson why and what you can do if you make that mistake. So 16 times 3 is 48. 16 is the perfect square. The square root of 16 is 4. Square roots of 3. Okay. All right, so let's step this up one little step. What happens if in our expression we have a number out front? That means that the square root of 18 is being multiplied by 5. So the way I'll teach it to you this time is, let's just ignore that number at first. What's the largest perfect square that goes into 18? It's 9. Times 2 is 18. Square root of 9 is 3 square roots of 2. Now this 5 out front means that there's 5 of these. 5 times 5 times. 5 times 3 is 15 square roots of 2. And again, you can check yourself. 5 times the square root of 18 is 21 point and some numbers. 15 times the square root of 2 is the same thing. So you can prove that you're correct. Let's try another one. So the perfect square 4 goes into 28 7 times. The square root of 4 is 2 square roots of 7. But on the outside we have a 3. 3 groups of this. 3 2's is 6 square roots of 7. Great. In your notes there was a typo. I apologize. This should read 5 square roots of 72. Now see if you can solve that. Give it a pause. You can push play again. 36 goes into 72 two times. The square root of 36 is 6 square roots of 2. So the square root of 72 can be simplified as 6 square roots of 2. But there are 5 of them, and 5 sixes is 30, and then bring down the square root of 2. Okay. Now I said just a few minutes ago that I would explain what happens if you don't pull out the largest perfect square. And so let me please show you what the difference is and what you can do to get around that if that happens. Okay, so the largest perfect square that goes into 1,000 is 100 times 10. And the square root of 100 is 10, square roots of 10. And then we have 2 of these, because there's a 2 on the outside. 2 times 10 is 20, square roots of 10. That would be the easiest or quickest way to solve that. But what if, for example, you said, oh, but 4 goes into 1,000 times 250. There's nothing wrong with using 4 as a number that goes in because it's a perfect square, but it's not the largest one, okay? So the square root of 4 is 250. Nope, square root of 4 is 2, sorry. And then the square root of 50. That's what I get for writing and talking and thinking all at the same time. Sometimes things come out goofy. And so you get the end result of 4 square roots of 250. Well, hopefully that looks wrong to you, because you may see right away, there's a perfect square factor that goes into 250. 25 goes into 250 10 times. Square root of 25 is 5 square roots of 10. And then there's the 4 on the outside. There's 4 groups of that. 4 groups of 5. 4 times 5 is 20 square roots of 10. So you get the same results, but literally twice the number of steps. So if you get a solution like this and you recognize that the number within the radicand is, or the radical symbol, this is the radicand, can be broken down further with factors that are perfect squares, then you can either start from scratch and pick a new perfect square from the top, or you can continue to break it down moving forward. And then, of course, if you go through this whole process, please go back and check your work. So the big takeaway from this is that the solution is the same, but if you use the largest perfect square, it takes less steps. Okay, take a moment and try these last few examples, and then I will talk you through them. Okay, the largest perfect square that goes into 128 is 64 square roots of 2. I believe 4 would also go into there, right? Square root of 64 is 8 square roots of 2. There's 3 groups. 3 times 8 is 24 square roots of 2. 9 is the largest perfect square that goes into 27. 9 times 3 is 27. The square root of 9 is 3 square roots of 3. 8 of those is 24 square roots of 3. And finally, yes, I know that 4 goes into 18, but 16 is a larger perfect square. Did I say 18? Sorry, 80. 16 is a larger perfect square that goes into 80. It goes in 5 times. 16 times 5 is 80. Square root of 16 is 4. Bring down the square root of 5. 4 groups of that for this 4 here. 16 square roots of 5. And then, of course, please go back and check your work by using a calculator to find the decimal equivalent of both, and that will prevent a lot of errors. Okay, so let's talk about the corresponding practice for this, because it may make perfect sense just watching it, but actually doing it independently is what forces you to put pencil to paper and really see if you know what you're doing. So this is just like what we did in our notes. Simplify each expression. So find the largest perfect square that goes into each irrational number, and then simplify. And yes, I would love to see your work, please, because I want to know what factors you are using. I want to make sure that the factors that you're using are perfect squares. Feel free, if you'd like, to use this or to write down your perfect squares down the side of the page so that you have that for your reference. So the top two rows are the simple ones here. The bottom two rows have the number out front. So let's see, the square root of 9 and 6 multiplied together are 54. Square root of 9 is 3 square roots of 6, but don't forget that 3 out front, and 3 threes is 9 square roots of 6. And that's how that goes. Okay, if you're still struggling or if you have questions that I didn't resolve for you, please feel very free to email me here, and I'm glad to help you any way that I can. Also, you guys know where to find me in class too. Thanks a bunch. See you soon.